Hot take: if your RAG answers are bad, your re-ranker might matter more than your embedding model.
That sounds wrong until you separate two jobs. Embeddings help you find candidates. Re-rankers decide which candidates deserve the top spots.
So this is not one model doing search better. It is two models solving different failures.
Exactly. The embedding model turns text into vectors so similar meaning lands near similar meaning. That lets you search a giant corpus fast.
But near is not the same as right. That gap is where teams get burned.
Concrete example: a user asks, how do I rotate AWS access keys without downtime? The embedding model may retrieve docs about key rotation, IAM basics, secret storage, and deployment steps, all related.
And the re-ranker steps in after retrieval and says, these 12 are in the ballpark, but these 3 actually answer the question.
Right. A re-ranker reads the query and each candidate chunked together and scores relevance more precisely. It is slower, but much sharper at ordering.
So embeddings optimize recall. Re-rankers optimize precision at the top.
That is the cleanest mental model. Retrieval asks, what should enter the room? Re-ranking asks, who gets the microphone?
Why can't I just buy the best embedding model I can afford and skip re-ranking?
Because vector similarity is a blunt instrument. It is great for broad semantic matching, but weaker at subtle intent, constraints, negation, and tiny wording differences that change the answer.
Give me a case where that subtlety becomes expensive.
Say your support bot handles refunds. Query 1 is, how do I issue a refund after shipment? Query 2 is, when is a refund forbidden after shipment? Those share vocabulary, but the second hinges on a denial condition. A re-ranker is more likely to put the policy exception above the generic process doc.
So if the wrong chunk lands in position 1, the generator sounds confident and your company eats the mistake.
Exactly. In RAG, top-ranked context has power. It shapes the answer disproportionately. Winners and losers are often decided in the first few chunks.
Then, when should a team improve embeddings first, instead of re-ranking first?
Improve embeddings when retrieval recall is weak. If the right document is missing from the candidate set, re-ranking cannot rescue you. You cannot promote a document that never arrived.
What are the symptoms of low recall?
You inspect failures, and the answer exists in your corpus, but none of the top 50 retrieved chunks contain it. That points to embeddings, chunking, metadata filters, or query formulation.
So this is upstream failure. The net is not catching enough fish.
Yes. Example: your engineering wiki uses internal names like Project Atlas, but users ask for customer-facing names like Migration Pipeline. If embeddings do not bridge that vocabulary gap, the right pages never show up.
And when do you improve the re-ranker?
When recall is decent, but ranking is messy. The right chunk appears somewhere in the candidate list, maybe at 15 or 30, and your generator only sees the top 5. That is a re-ranking problem.
So the system is finding truth, then burying it.
Perfect phrase. Example: legal policy search. Retrieval brings back 10 clauses from the right contract family. The re-ranker should recognize that the clause mentioning renewal notice in California is more relevant than a broader termination clause with more lexical overlap.
There is also a cost game here, right? Bigger candidate sets help recall, but then re-ranking more chunks costs latency and money.
Yes, and this is where architecture becomes strategy. Better embeddings can reduce how many candidates you need. Better re-ranking can let you keep retrieval broad without sacrificing answer quality. You are trading recall, precision, latency, and spend.
Which mistake is more common in early RAG systems?
Teams often blame embeddings for what is really a ranking problem, because they only look at the final bad answer. But if the right chunk was already retrieved, swapping embedding models may change little.
So evaluation has to split the pipeline. First ask, did we retrieve the answer anywhere? Then ask, did we rank it high enough to matter?
Exactly. Measure retrieval recall at K, then rank quality at a smaller K, then answer quality. If you collapse those into one score, you hide the fix.
That changes how you spend effort. Stop treating search as one black box and start asking where the failure actually happens.
Because embeddings find possibilities, rerankers choose priorities, and in RAG, the best system is not the one that knows the most. It is the one that puts the right evidence first.